velocity and acceleration. Yeah, excellent. All right, so let's say you have a position function s of t, right? The velocity would be the first derivative of your position, and the acceleration would be the second derivative of your acceleration. Truth? So would you say that to find the velocity, you would just integrate the acceleration? Yay. All right. So here's one. Find v of t given a of t and v of 0. So we know a of t is equal to 4 t minus 6. So to get v of t, you would just take the integral of 4t minus 6 dt, which equals t plus c. Okay? All right. Thank goodness we have a little bit more information. We know that the velocity at 0 is equal to 3, and that's your constant, that's your c. Okay. So therefore, v dt is equal to 2 squared minus 6t plus 6. Okay? Let's do it again. All right. Here we go. This time the acceleration is sine t plus 2t. So v of t would be the integral of that. So cosine t plus t squared plus, yeah. And again, since v of 0 is 5, that's c, so v of t is equal to negative cosine t plus t squared plus 5. Is it 5 or 6? Oh, sorry, it's 6. What am I doing? Negative cosine. Oh, at 0, yeah, so v of 0, my bad, is negative 5 plus c, right? Which is equal to 5, so that means c has to be, I'm sorry, negative 1 plus c. Yeah, when you plug in 0, yeah. Negative 1 plus c is 5, so therefore c has to be 6. Thank you for catching that. I was getting lazy. Okay. Okay. And the next line is exactly what Alejandro said. So distance is how far you traveled. Displacement is the difference between the distance where you started and stopped. And then displacement is equal to distance when? Yeah. Motion is always forward. Joy? So, point is, if it's asking for distance, it's not necessarily the same as asking for displacement. It must always be in a straight line. Okay? So in example 3, a particle is moving along that line. Oh, yeah. So there's the formula. So displacement, just take the integral for distance, so you take absolute value again. That falls like plus 2 once it stops. So, for example, in number 6, right, we know, drawing a graph of this thing, the factors of this thing are going to be 2 and 5. Okay? And it's going to go something like this. It's positive y-axis. Okay. So displacement, that's easy. Just take the integral from 1 to 7 of t squared minus 7t plus 10. Okay, sorry. Yeah. did you get when you integrated? Minus 7t squared over 2. Right? From 1 to 7. Is there a 10t? Oh, 10t! That's it! Silly! Alright, yeah. Plus 10t from that changes it. Thank you. No one has a calculator on. That's very brave. Shut up! What calculator? Shoot. Yeah, because 7 cubed is such a common number. 77 over 6? I don't think that's it either. Yeah. Let's do this. So does 3 go into 343? The answer is nope. Okay. Nope. I don't. Let's see. Hang on. Yeah. Alpha y equals 1. 7 cubed over 3 minus 7. I'm just gonna double check, but yeah, that's what I got originally. 1, 7, 2, yeah. No one knows. Yeah. 7 times 7 squared is so 49. Yeah. Plus 10 times 7. No one's judging. I don't know. Anyway, yeah. Here we go. We believe it. Here we go. Yeah, you're supposed to get 6 for displacement. Yeah? Sure. Okay. I mean, it worked. It's alright. Okay. Guess what? Did I mess up? Yeah? Okay. Alright. Distance on the other hand, which I'll do over here. Distance is a little bit more blah. Because you have to take the integral from 1 to 7 of the absolute value of t squared minus 7t plus 10 dt, which means you only want positive stuff. Okay? So this area right here is positive. That's fine. But this area here is negative. So what you have to do is take the opposite of that area and flip it around the other way. And take that area plus, I think we're going up to 7, right? So we up to there. Okay? So it looks like we go from 0 to 2, 2 to 5, we have to flip that area, and then 5 to 7, back to normal. Yeah? So, to find the distance, again, you're going from 0 to 2, or sorry, is it 1 to 2? Whoops! Yeah, we want 1, not 0. 1, 3, because it's 1 to 7, right? So, from 1 to 2, you just take the normal function, so t squared minus 7t plus 10 dt. But from 2 to 5, you have to flip that value. So minus integral, right? Negative of it. From 2 to 5 of t squared minus 7 t plus 10 t. Sure. And then it's back to normal from 5 to 7. So, yeah. So, do you want to try? You don't have to be here. Oh, you do. Okay, good. Remember I plug in, no one has a calculator. What? It's, why are you talking like that? It's following the actual function. So you're finding the area under the curve of that function from 1 to 7. So, yeah. No. Yeah. If you plug it in.
I think the easy way out was to do it by hand.
I'm curious to see if this works. Just curious. Yeah. Nope. Seriously? You know, here I was, thought I was going to college. What's math interval F in there? F int. So I'm doing, yeah, fn int. And then from, oh, wait. Yeah, from 1 to 7. And then second catalog absolute value of x squared. Yeah. Minus 7x plus 10. And then dx. I don't know. I don't know. It's okay. Yeah. Answer is 15. Yay, calculator! I mean, paper too, right? Yeah, it's all good. Oh, wait. Oh. Oh. That back page is a picture of what I just graphed. So again, you can see what they did to that curve. To subtracting it just flips it over to the positive values. Oh yeah, and the calculator thing's right here. If you have like the old one that doesn't do the integral for you, you have to like plug it in. Yeah, it goes function, variable, lower, upward. Yeah, man, good times. Okay, let's do another one. Here we go. We know that an object moving in a straight line has an acceleration of square root of t in feet per second squared. The velocity at time 0 is negative t. T is 0 to 16. Find the velocity and displacement and distance. What? 3 things. Gosh darn it. All right, let's do it. Velocity. micro. A small T. There's the micro. There you go. Yeah. 2/3 T to the 3/2 plus C. Okay? Yeah. Okay. So when you plug in 0, it's just C, so it's -18. So the velocity at T is equal to 2/3 T 3/2 minus AT. There's more. Joy. All right. So the displacement. Wow. What? Yeah, I know what you said.
No, I said.
Oh. It's all good. Would be the displacement. Good on you, mate. Oh, I'm gonna stick that in a calculator. Want to do it? No? You don't? Come on! You don't have a calculator is what it is. Alright, I'll give you a calculator. Come on, man. You guys spent all that time on this stuff. Jimmy cracked corn. Here we go. Try it. Try it. Try it. Do it. So, oh my gosh. Oh my gosh. Oh my goodness gracious. I mean, you can if you want to. Oh yeah, 0 to 16. Thank you, sir. I didn't even write that. 0 to 16. I like that. Mom, this fight for a calculator us today. Supposed to use it. Yeah. Say it. It is negative. Really negative displacement. Negative.
Don't say what the number is.
What? 14.
Literally almost.
Is that? Okay, so the distance would be the same thing except absolute value of 2/3 T to 3/2 minus 18 dt. Wasn't that funny? Isn't that funny? You're done. Resisting. Seriously? I know. It makes it go by so much faster because you have 13 questions that take an hour each.
I don't know how.
They're like jack off meter. You show them something, you're like, oh, then how would that work for magically? Jack. What is it? Oh. 7. I like it. I like it. Yay. So, question, did Better make you guys do the car project where you ride along in a car and then you write down, like someone's driving and someone else is like writing down your like velocity, your speed at every moment? Really? On your way home there, Nick? You didn't do that? Okay. Whichever. All right. Here we go. A Dan and what problem? I okay. Oh, I feel bitterness. Here we go. Once upon a time, a subway train accelerates as it leaves the station, then decelerates as it comes to the next station. Apparently, it takes 60 seconds to get to the next station. That's crazy. All right. The following chart measures the velocity v given in miles per hour. So the velocity is in miles per hour. Find the distance it travels every 5 seconds. That's easy. At 0, how far did it travel? At 0. Yeah? Now, to find the average velocity, because it's moving every 5 seconds, you just take like the first one, so the velocity 1 plus the velocity 2, and then take the average of it. Yeah? And multiply that by, how do you change seconds to hours? More. 3,600. 3,600. Yeah? Are you talking about degrees to seconds? Yeah. Did you? I don't know. Alright. So, for example, so the next velocity would be like 0 plus 15 divided by 2 times 5 divided by 3,600. Did I not do it? What, I did what? Oops. 0. So 15 divided by 2 times 5 divided by 3,600. Did I mess up? Did I multiply by 2? Or divide by 2? Oh! Times 7.5. Dirt to dirt. That's better. Okay, so the next one is 0.010. So what would the next one be? How would you solve that one? Okay. Yeah, the 0.30 or 0.03? Yeah. So this one should be 0.033. Like it's. Is it 13333?
No. Because you're adding all this stuff.
I think it's. No, so that's what we have to do is add up the distance all together at the very end. Yeah, at the end. Yeah. 33 minutes. Yeah. So 15 seconds. Yeah, well, 0.52. I'll write this code. 0.052. Toy. 44 seconds. Huh? Well, maybe. Yeah, 0.059 something. So would 0.060 work for that one? Yeah, okay, that's where I got that one. 0.060. Then 44 plus 44 divided by 2. 0.061, yeah. 0.061, and I believe you do it again. 0.061, and again. Then it's starting to slow down, so down to 43, back to 0.060. Okay, at 38. That's not what I got. 5. That's it. Oh, no. Yeah, the next one is 0.056. Then, 0.043. Notice my handwriting is getting bigger and bigger. It's translated. 0.22. And when it comes to that slow stuff, choo-choo. Does that thing run up to 6 or no? Yeah. It does? Okay. So the last one is 0.006. Add it all up to find the total distance.